This is the explanation for the test number 19 regarding hydrodynamics. So in this test, we'll be mainly focusing on the continuous equation and Bernoulli's equation. And this is also the final test from the S0 series. So that was regarding mechanics. So after this, we'll start the next unit, the test series for the next unit, that is waves and oscillations. So that will be S1 series. Okay. So the students who participated in these tests have a real solid understanding of mechanics. Okay. We'll move on to the first question. An incompressible fluid flows through a pipe at rate of 22 cubic centimeters per second. Speed of flow where the radius is 3.5 centimeter is. Okay. So this is the incompressible fluid. So we can apply the continuous equation. Or just you can apply a volume flow rate, right? Let's say V divided by T, volume divided by time, that is volume flow rate. You know this equation AV, cross section times velocity. So for the volume, we can consider cross section times velocity of the fluid as the volume flow rate. Right. So the volume flow rate is given as 22 cubic centimeters per second. You don't have to convert this, right? Because the answer is also in centimeters. Cross section. They say about the radius. So they have given radius as 3.5 centimeters. 3.5 means 7 over 2, right? So I'll substitute it as 7 over 2. Phi r squared, that is cross section times velocity. So what they ask is velocity. Okay. So this phi means 22 over 7. This is 7 over 2, 7 over 2, V 22. Then just cancel. 7, 7 cancels. This is 2 times 2, 4, goes to the other side. 7 comes to the denominator. So the answer should be in centimeters per second. Velocity is 4 over 7 centimeters per second. Right? So it should be the third answer there. Right, second question. Through a funnel, water flows steadily. At the lower end of the funnel, with diameter d1, water flows at speed v. So let's say here the diameter is d1 and the water flows at v. Here the diameter is d2. Let's say water flows at v2, right? So for this one, you can see you need to apply the continuous equation. So what is the continuous equation? A1 V1 equals A2 V2. Here the volume flow rate is equal to here the volume flow rate, because we use incompressible fluids. Else you have to assume the incompressible fluid when you apply this equation, the continuous equation. Right. So here A1 is what? Phi, diameter is d1 squared. But you have to divide diameter by 2. When it gets squared, there's a 4 here. V1 means just V. Here A2, pi. Here you have d2 squared divided by 4. Then you have V2. So what you have to find is that V2. Pi cancels off, 4 cancels off. d1 squared V divided by d2 squared. So this is V2. d1 squared V divided by d2 squared. Right? So that is simple, right? So usually for this question you don't have to, but for a question when you have to apply a Bernoulli's equation, first you have to apply continuous equation, then Bernoulli's equation, right? For this one we don't have to. So the answer there should be the fourth one. right? So these questions are simple, right? Because this is a simple equation. Right, third question. A water shower pipe with radius 8 millimeter is provided. So this is 8 millimeter radius, right? Radius. Then this is the shower and it has 50 holes. 50 holes. Water provided. Inside the pipe, the speed of water is 2 meters per second. The shower has 50 holes and each hole, the radius this is 0.4 millimeters. Speed of water through a one hole. So let's say that is V. So for this one as well, you can see the water through this pipe, flow rate through this pipe is equal to the total water flow through all these holes, right? So how do you write that? A1 V1, let's say here, is equal to here, A2 V2. So here A1 is just 5. Again, you don't have to convert units because millimeters, they will cancel off. 5 radius is 8 squared times velocity is 2 times then A2. So these are small holes. So let's say for a one hole, I can write 5 times 0.4 squared for a one hole. And there are 50 such holes, right? So this is the cross section at the second part that the water flows. You have to multiply by 50, right? Okay. Times velocity of water flow through a one hole. Okay, so these two are equal. Then just 5 pi cancels off. Then this is 8 squared times 2 divided by 50, cross multiplying, right? 0.4 squared means 0.16 actually. If you want, you can take 8 squared as 64. So this is V. 0.01, I'm dividing by 16, right? This 16 and this 16. How many 16s? There are 4 16s here. So if you multiply 50 by 0.01, you get 0.5, right? 0.5 means half. When it goes up, it becomes 2. 2 times 2, 4. 4 times 4, 16. Since here we substituted the velocity in meters per second, here also you get in meters per second, right? You can see that millimeters cancels off from the both sides. So what is remaining is here meters per second. You don't have to convert all those units in this case, right? So the answer is 16 meters per second. Right, fourth one. Water falls steadily through a pipe with cross-sectional area 10 to the minus 4 meter squared at 1 meters per second. So it is a tap, right? So from here water falls and the speed of is given as 1 meters per second and the cross section 10 to the minus 4 square meters. So you might have noticed that when you slightly open the tap, the water flow, this is the water flow from the tap, gets a shape like this, right? It gets narrower as it falls down. So when you open the tap loosely, it is a laminar flow, right? If you fully open the tap, then it is going to be a turbulent flow. For a turbulent flow, we cannot apply any of these equations. But here you have a laminar flow. For a laminar flow of water, you can see that it gets narrower. So why does this happen? you know that this water falls under gravity, so it accelerates, so the speed of water increases. So when the speed increases, what happens? So we know that AV is a constant. When the speed increases, cross section of water decreases, right? That's why it gets narrower as it falls down. So what they ask is below 1.2 meters from the tap, cross sectional area, let's say A, and here you have, they have given the velocity V. So what they ask is cross sectional area of this water flow 1.2 meters below the tap, right? So simply you just have to apply continuous equation. So A1 V1 equals A2 V2. Before finding that, we don't know A or V. You need to find V first, right? So how do you find that? To a water particle, just apply this motion equation. So the water is falling under gravity, right? So U is initial velocity, that is 1, right? Not 0. It is 1 plus 2. This is gravity, so 10. Height is 1.2. Okay. So after this, you need to write the value of V. Don't go for another step, like in O-level times, right? This is how you do it. 10 times 1.2, 12. 12 times 2 is 24. 24 plus 1, 25. Then you need to take the root. 25 root means 5, right? Okay, so the velocity here is 5 meters per second. You need to avoid writing too many steps when you are doing calculations, okay? Otherwise, the time will not be enough, okay? When you are facing the A levels, right? So here, this is the first case, this is the second case. At the first case, cross section is 10 to the negative 4, velocity is 1. Here, cross section is what we need to find. Velocity, we found it as 5 meters per second, right? So A2, 1 over 5, right? 1 over 5 times 10 to the negative 4. What is 1 over 5? It is 0.2, right? 0.2. So you can write it as 2 times 10 to the power minus 1. Then it becomes 2 times 10 to the power minus 5 square meters. So this is the cross section here. So you can see it has narrowed, right? From minus 4 to minus 5 times 2. Okay. Right. Fifth question. An incompressible fluid with density 800 kilograms per cubic meter flows through the first end of a pipe at 2 meters per second. Here the speed is 2 meters per second. Two ends of the pipe have cross sections with diameters. Here you have 1.4 centimeters. Here you have 0.7 centimeters. Pressure difference in Pascal between the ends is. So let's say here the pressure is P1, here the pressure is P2. Okay. So you can see to find the pressure difference, you need to apply the Bernoulli's equation. You need to apply Bernoulli's equation. Before applying that, you might want to find the velocity here. So let's say that is V2. So how do you find velocity there? You have to apply continuous equation. So usually you do that, right? In most cases, when velocity is involved, you have to apply continuous equation and find the velocities first before applying Bernoulli's equation. Not in all cases, right? But right? Okay, so this is the first case. The second case, so volume flow rate here is equal to volume flow rate there. So here A1. So 1.4 is diameters, right? Yeah. Again, you don't have to convert units because it cancels off from both sides. So A1 is pi. Diameter is 1/4 squared. So I have to divide by 4, right? Because diameter. Velocity is 2. Here A2 is 5. Diameter 0.7 divided by 4 is squared. Then the V2. You need to find V2. Okay, 5 cancels off. 4 cancels off. So you can consider this to be like 1.4 divided by 0.7. You get 2, right? 2 squares. 4. 4 times 2, 8. So I get the answer in meters per second, right? Here meters per second, here meters per second. Right, so we found the velocity. Okay? Right, then we have to apply Bernoulli's equation. So you know that Bernoulli's equation is applied to a streamline, right? So you can consider this streamline, right? Okay. So the total energy per unit volume. So what's Bernoulli's equation? P1 half rho V1 squared plus rho GH1 equals P2 plus half rho V2 squared plus rho GH2, right? Here, if you consider a P equals 0 line, you can see this point has the same height, right? H1, H2, they are equal, right? So you can get rid of this term first. I'm explaining this because this is the first question regarding Bernoulli's equation. But later you don't have to even write this rho GH term, right? This, for many questions, you don't get rho GH. Only for that question like the water leaving from a vessel, right? Only for that question you mainly get rho GH. Otherwise, you only have to write this pressure and the kinetic energy of unit volume. But you have to be careful, right? The question could change. If you feel like this is not important, you don't even have to write that, right? Okay. Another thing is you need to then understand. So this is the equation, right? For this question, another thing is you need to understand whether the pressure is higher or lower, at which end. So you can see the velocity here is higher. If velocity is higher, pressure is lower. You need to have that concept there, right? When you are thinking about Bernoulli's equation. When the velocity is higher, given that rho GH is neglected, right? When the velocity is higher, pressure is lower. You have to understand that. Velocity is higher, pressure is lower. If velocity is lower, pressure is higher. So here, you can see, since the velocity is higher, P2 is lower. P2 is less. P1 is larger. P2 is less. Okay? Right. Then you can see, then you have to take P2 to this side. P1 minus P2. Put the other terms to the other side. I'm taking half rho out. So this is V2 squared minus V1 squared. So this is the equation. If you have done so many questions, you can directly think about this equation, right? When it is an MCQ, just directly apply this equation. So this is the pressure difference. So you can avoid all these, right? I just explained this because this is the first question. After this, I'm going to apply this at once. Okay. So for delta P, but you have to make sure that rho GH is negligible, right? In order to apply this. Okay. Half density is 800. Velocity is V2, that is, we found that 8. 8 is squared minus V1 is 2. Right. So we have 400 here. Then this is 64 minus 4. That is 60, right? 6 times 4, 24. There are 3 zeros. Pascal. 24,000 pascals. So that's the pressure difference between the ends. Fourth answer. Right, sixth question. Two cross sections of a pipe having radii 0.1 meter and 0.05 meter. Pressure difference, so let's say here P1, P2. Pressure difference is 75 Pascal. If the density through the pipe is 1000 kilograms per cubic meter, volume flow rate is, so the asking is AV, right? Okay. So before all this, I'll just apply continuous equation. So A1 V1 equals A2 V2. I'll say velocity here is V, right? Let's say velocity here as V dash. So I need a combination between V and V dash. Okay, so A1, that is pi r squared, 0.1 squared, equal times velocity equals A2, 0.05 squared, times velocity here I took it as V dash. There's pi. Pi cancels off. So you can see this is, when you divide 0.1 by 2, you get 0.05, right? So when you take it here, it is 1 over 4, right? 1 over 2, but it gets squared. So 1 over 4. So it is V over 4. Sorry, not V over 4. Here it is, let's calculate that. 0.1 is squared divided by 0.05. You can put the power commonly. You cross multiply. Then V dash. So when you divide this, 0.1 means there are two 0.05s to 0.1. 2 square is 4. So V dash is 4V. Okay. So here the velocity is V. Here the velocity is 4V. Okay. Here velocity is V. Here the velocity is 4V. You didn't even have to find that, right? Without applying this, you can see, because this is a MCQ, right? You don't have to do all these. You can see the cross section is halved. I mean, not the cross section. Radius is halved. So the factor change of radius is halved. But you know that cross section gets squared, pi r squared. So the factor also gets squared. So the factor becomes 1/4. If the cross section becomes 1/4, then the velocity has to increase by a factor of 4. So if velocity here is V, velocity here should be 4V, right? You don't have to do these things, right? For essay question, you can do that, but for MCQ, it is not necessary, right? Without doing those things, it is really difficult to manage time, right? You need to practice those shortcuts. Otherwise, it is not possible to get 50 MCQs within 2 hours, okay? Right, so the here velocity is V, here velocity is 4V. So we resolve that. So what they ask is flow rate. then the equation we have to apply is the Bernoulli's equation. I'll apply this at once, right? For an essay question, you might need to derive this. You cannot apply this at once. Usually they ask you to derive this first for an essay question, right? But for MCQ, you can remember this. So, okay, so half density is what? Is it water? Okay, 1000, right? So water, 1000. Here V2 is this one, so the velocity is 4V squared minus V1 squared, V squared, right? And the pressure difference is given as 75, right? Okay. So if you want, you can multiply this here, so it becomes 150,000. 4 squared means 16 minus 1, 15. Then V squared gets out, right? 15 cancels off. 1 cancels off. 1 over 100 equals V squared. You have to carefully do these calculations, right? So 1 over 100. Okay, so V is what? 1 over 10. Take the root. So it is 0.1 meters per second. So we found a value for velocity, that is 0.1 meters per second. So this is not what they ask. What they ask is flow rate, right? So either to this or this, you can apply AV. AV is the flow rate, right? Be careful there, but right? You have to make sure whether it is this or this. Don't mix those two, right? So volume flow rate, AV. You have to make, don't take this cross section and this velocity, okay? If you consider in this point, you have to consider this cross section and this velocity. You have to make sure that. Okay, so the cross section here is what? That is pi r squared. Okay, pi, radius is 0.1 squared, velocity is v. So it is 0.1. So 0.1 means 0.3, 0.1 to the power 3. So it is 10 to the power minus 3. So that is pi 10 to the power minus 3. So the unit should be cubic meters per second, right? Cubic meters per second. So the answer should be fourth one, okay? So here I just applied these two first case. Someone could apply that to here, right? But you should get the same answer if you correctly substitute the values. I'll just show how to apply it here. Okay, if you apply it here, so pi r squared is 0.05 squared, 4v, right? 4v, 4 times velocity, 0.1, right? Then pi times, you can consider that 4 to be 2 squared, okay? Then 0.05 times 2 squared. You can take these powers to 1 bracket. So what is this? 0.1, right? 2 times 0.05 is 0.1. 0.1 squared, 0.1, 0.3 cube. So again you get the same answer, right? But you have to make sure here you have to multiply by 4 here, right? I have seen students confuse that up. So are you careful when you are applying either to this one side or this side. Right. 7th question. When a coconut is punched, its water jumps a height of 1.6 meters. Additional pressure built in the coconut water is. So you have a coconut here. So you cut it. You can see that water shoots up, right? So why it is pressurized? there. The water, coconut water, is pressurized inside. So when you cut it, that pressure releases with the liquid, right? So it goes up. You can see that pressure difference is equal to the rho GH. So the kinetic becomes kinetic energy, but it goes upward, up, and totally converts into rho GH. So you can write this equation, delta P is equal to rho GH. That pressure also is energy, right? Energy per unit volume. That is, I mean work per unit volume, that is pressure, is equal to potential energy per unit volume, rho GH. So what they ask is delta P. So coconut water, that is 1000. Gravitational acceleration, then H is given as 1.6. So 1.6 times 10 to the power 4 Pascal. So that should be 16,000 pascals, right? 16,000 pascals. Eighth question. An airplane with effective wing area, capital A, and mass capital M has a pressure P on top of its wing. If it moves horizontally, pressure below the wings is. So I'll only draw wing, right? The effective area is given as A. Effective area is considering all the area, right? And it has a mass capital M, so the weight is mg for the plane, right? Then you know there's uplift, I mean lift. If it moves horizontally, I mean parallel to the ground, this lift and mg should be equal, right? Otherwise it either goes accelerate upwards or accelerates downward. Here you can consider that F is equal to mg. Only here, right? But there can be other cases that the airplane is accelerating or decelerating, upwards or downwards. If there's no upward or downward motion, acceleration, you can see that lift is equal to the weight. Lift is equal to the weight. Right. So how do we get this F lift force? So you know that it is equal to pressure difference. Let's say they say pressure here is P. Pressure here is, let's say, P1. So usually you know that here the velocity is smaller. Here the velocity is larger because it has to move a larger distance, right? Velocity is higher here, so the pressure is lower. So whenever the velocity is high, pressure is lower, according to Bernoulli's. So this is the low pressure, this is the high pressure. So that is what creates the lift. So it is applied across a capital A area. A times pressure difference. Okay, now you can just apply it here. A times P1 minus P2, P equals mg. So what they ask is P1. So P1 minus P equals mg over A. So P1 is equal to P plus mg over A. P plus mg over A. So that is P1, pressure here. Okay. So for this question, we didn't have to apply Bernoulli's equation. So to apply Bernoulli's equation, we need velocities, all those. You don't have to, right? Because there's no acceleration upwards or downwards. But if there's an acceleration, you cannot say that you cannot apply this one, right? Right. For the ninth question, mass of an airplane is 200 kilograms and its effective wing area is 4 square meters. Area is 4 square meters. The mass is given as 200 kilograms. Speed of streamlines above and below. So the above, it has a 60 meters per second speed. Below, it has 44 meters per second. And the density of air is given as 1.3 kgm minus 3. Pressure difference between top and bottom of the wing. So here let's say P1, here let's say P2. Okay. Right. So for this one as well, you know that rho GH term, if they don't especially mention that, you can neglect this. You learn this in theories, right? Rho GH, you can neglect that. So if that is the case, you can say P1 minus P2 is equal to half rho V2 squared minus V1 squared. So this is the first case, second case, right? So some students confuses that whether to write P2 minus P1 or P1 minus P2. So prior to that, you need to understand that low velocity, so this has the high pressure. So it should be P1 minus P2. Even though you got P2 minus P1, you will get the answer, but it is better to take positive values, right? Then it will be easier, bit less complicated. Right, so it is P1 minus P2. Okay, so what they ask is this pressure difference. Okay, so deriving this is different, right? You know that you have to apply this along a streamline, right? Then you get this pressure difference. You cannot apply Bernoulli's equation here and here. But at the end, what you get is this one, right? I'm not going to derive that because these are MCQs, right? Okay. Okay, so half rho is what? 1.3. V2 is 60 squared minus 44 squared. Okay. So half times 1.3. So 60 minus 44, that is 16, right? 60 minus 44 is 16. 60 plus 44, that is 104. You have to use those, right? Don't just square and take the square of this one. You have to be smart when you are doing calculations. 60 minus 44 is 16. 60 plus 44 is 104. Right. Now I'll divide this one. 16, 8. So I'll just multiply this. 832 times 1.3. There's a calculation. So it is 832, 13, 6, 9, 24. So if you are not practicing these shortcut methods when you are doing simplifications, then the questions are going to get hard, right? They are going to get complicated, right? Yeah, you need to practice these simplification methods to get the answer quickly, right? 6, 9, 24, 2, 3, 8, 6, 11, 8, 10. So there's a one decimal. So 1081.6 Pascal. So that's the pressure difference. So did you notice that for the previous question 9th, we didn't get F equals mg, right? Because they don't say that. Because they don't say that lift is equal to mg. So we cannot use that. So we used Bernoulli's equation in order to find the pressure difference. Okay, so that is the difference between 8th and 9th questions. So you have to notice those. Okay, right. 10th question. Mass of an airplane is 250 kilogram and the area is 6 square meters. Speed of air streamlines above and below the wings is here 60 meters per second, below 50 meters per second, right? If the density of air is 1.2, lifting force. So what they ask is lifting force. Before that, you need to find delta P. That is half rho. This one. Half rho. Density, is it given? 1.2, right? That is density of air. V2, that is 60 squared minus 50 squared. Okay? Right. 0.6. So 60 squared minus 50 squared. You are not going to find 3600 and 50 squared. It is better to go like 60 minus 50. 60 plus 50. Right? Better to go like that. Always use the simplest way to get the answer. Okay, 0.6 times 10, 6. 6 times 110 is 660 Pascal. So that's the delta P, 660 Pascal. Do we have an answer? Sorry. This is just delta P, right? But they ask is lift, right? So the lift is, you have to multiply that by area. A times delta P. So the area is 6. Delta P is 660 Pascal. So 6 times 6, 36, 3, 39. Then there's 0. 3960. So the answer should be the second one there. Right, 11th question. Liquid level is at B inside the capillary tube shown low in air through the horizontal pipe. When air is blown, so what they ask is what happens there, right? But they could give you a question based on this as well. But here they just ask what happens. So when air blows here, what happens is this liquid column rises to the top, right? So this is the application. In theories, you derive this in a sprayer. Okay, so it climbs up. So that is what you know. So the answer should be first one, right? Answer should be first one. So if I explain this qualitatively, you can see, let's say pressure here is P1 and the atmospheric pressure is P0. So atmospheric pressure, the air is still, so the pressure is high. P0 is high, right? So here as well the pressure is P0. Then since the air is flowing here, P1 is less. Okay. So here the pressure is P0, here the pressure is P1. It is a less pressure. So what happens is the liquid goes up. The liquid column rises till the pressure difference become equal, right? Okay. Yeah. So P0 minus P1 is equal to, here it is hydrostatics, right? So it is going to be equal to H rho G, right? So once this liquid comes here, then it mixes up with the air here and leaves from here, right? So that is how the sprayer works. Right, 12th question. One end of a U-tube has half the cross-sectional area of the other end. So U-tube, right? If an air stream with density sigma flows above open ends P and Q, so let's say here P, here Q, so air stream, make sure the density here is sigma. Don't mix those densities up, right, with the liquid density. So the density of the air is sigma. Velocity, they say the velocity of air stream here is V1, here is V2, right? Not the same streamline. Could be because of other reasons, right? The velocities are different. Difference between height between liquid levels at P and Q is density of the liquid is rho. Okay. Okay. They don't say that whether which velocity is higher. So I'll just take V1 is higher, right? Doesn't matter. I'll just take V1 as higher velocity. Right. Anyway, you just have to get the positive answer. Okay. So V1 is higher. So if V1 is higher, P1 is lower, right? V2 is higher, V2 is lower, P2 is higher, right? Okay. So P1 is lower, P2 is higher. Since P2 is higher, this pushes down this liquid. This goes up, right? So what they ask is this height difference. Let's say simple h. They ask simple h. Okay. So you can understand here you have hydrodynamics. Here you have hydrostatics, right? So this is the liquid. Okay. So first I'll just apply Bernoulli's equation to this streamline. So you don't have to consider rho gh, right? You can see this is at the same level. Rho gh cancels off. Right? P1 is lower, right? This is important because otherwise it will be a bit messy. Okay, so I have to get P2 minus P1. P2 is higher. Is equal to the other side half rho V1 squared minus V2 squared. So this is the pressure difference, P2 minus P1. So this is regarding hydrodynamics. But for this liquid column, you have to apply hydrostatics. How do you do that? Here the pressure is P2. So here it has a hydrostatic pressure. Also here it's going to be P2. Here the pressure is P1. Pressure is P1 here. Pressure here is P2. Okay. So for the liquid, you know that at the same level you have the same pressure. So what's the pressure here? Hydrostatics. P1 plus H rho G. P1 pressure here plus H rho G pressure here is equal to P2. So from this one you can get P2 minus P1. Here rho is sigma, right? Because air pressure. The students mix that up. Make sure that pressure here is air, right? Sorry, density here is air. Here rho means liquid density. Don't mix those two. Okay, now we have two equations for the pressure difference. Then you just have to equate them. So half sigma V1 squared minus V2 squared equals H rho G. So what they ask is the height difference, that is simple h. So h is what? Sigma V1 squared minus V2 squared divided by 2 rho G. So that is the height difference. Right. 13th question. Two pressure meters placed in an airstream are shown below. 1 meter has a reading PS, another PT. Okay. Here you have Here you have PS, pressure. Here you have PT. Velocity of air stream is, right? So let's say velocity is V. So it has a velocity V. So you can see at here, the airstream stops, right? It cannot go like this because it is closed. So the velocity here is 0. A point like this we call stagnating point. Stagnating point. Okay. Right. So what they ask is V. Right. So all you have to do is just apply Bernoulli's equation to this point and this point. Again, no H rho G. P1. P1 is what? They say pressure measured here is PS. So the pressure here also is PS, right? This is hydrostatic pressure. It is measured the pressure like here. So it is PS. Plus there's a velocity to the air stream. So half rho V squared equals pressure here. It is measured as PT. And the velocity is 0. There's not, we don't have a H rho G term as well. Okay. So what they ask is V. Take this to the other side. So it is PT minus PS half rho V squared. Take 2 to this. 2 times PT minus PS divided by rho. Take the root. 2 times PT minus PS divided by rho, root of that. So that is equal to the velocity. Correct? So the streamlined velocity here V, then here the velocity becomes 0, right? So such a point is called stagnating point. You have such a, the application you use that is in a pitot tube, where you have to find the velocity of a air stream, right? So it is a similar application you apply. Right, 14. Water leaving from holes at A and B falls on the same place. Height of water level inside the vessel is. Okay, so we have water. Let's say this is B and this one A. So there are punch here, so it falls here, right? Falls to the same place. Okay. Then they say this height is H2, height difference between these two levels, and from the bottom to the top, this punch, the height is H1. So here what they ask is height of the water level. That's capital H. Let's say capital H, right? Okay. So this is a MCQ, right? So if you get a question like this, in the theories you have to have learned this one. You need to know that this height means depth to the first punch, capital A, is equal to this height. You need to know that this height and this heights are the same, equal. In that case, only water falls to the same place. Okay. So I'm not going to derive that. You need to know that, right? In theories, you have to learn that, right? You can derive that, but it is very long, right? You can derive it like this. If you haven't learned that, you can find the velocity here. Apply Bernoulli's equation. You can find the velocity here, right? So you have two horizontal velocities. Then you need to find this time using just motion equations. Then you know this horizontal distance. So each case you need to find horizontal distance in terms of these values, right? Then you can prove that this height and this height are equal, right? So I'm not going to derive that. You can try that, okay? Right. So we know that this height and this height are equal heights. Okay. So here now I'm going to use that. Okay, so this side I can write that in terms of these. That is going to be capital H. From here to here it is capital H minus H1. Capital H minus H1. It is this. Here, what is that? H1 minus H2. Okay, so these two are equal. So H1 minus H minus H1 equals H1 minus H2. So you can simplify in capital H. That is 2H1 minus H2. Okay. So if you know that, you can take the answer within like 20 seconds, right? If a student know that. If you don't, you have to do that tedious calculation and it is going to take like 10 minutes. Okay. So you have to learn this in theories that these heights are equal, right? Right. 15th question. A ball with radius r which moves with velocity v rotates capital N number of turns per second. Force created by air on the ball is. So you know that relative to the ball, you can imagine these streamlines, right? These streamlines, right? So when you turn the ball, what happens is if the ball rotates like this, so there's a roughness to the ball, right? Here the velocity is, I mean, velocity of air stream is v. Relative to the ball, actually the ball is moving, right? But you can consider that like the ball at rest and the air streams flow through the over the ball, right? So like that, you can find the pressure difference. So you can say relative to the ball, these streamlines has a velocity v. But the thing is, closer to the ball, since the ball is rotating to this side, the ball is rotating to this side and the air stream is moving to this side. Okay. So the velocity here should be what? Before that, you need to find tangential velocity of the ball regarding the rotation of the ball. So let's say that is r omega for now, right? So here the velocity, let's say this is first point, second point. Here the velocity is what? For the streamline, streamline is trying to move at v to this side, but the ball is rotating this side. So the net velocity here is going to be v minus r omega here, right? Air particles here will have velocity v minus r omega. Then think about air particles here. Air stream is trying to move to this side and the ball also is, this surface also is moving to this side. So the air stream has an additional velocity r omega. So the velocity here should be v plus r omega. Okay. So low velocity, high velocity. So if the velocity is low, you know that pressure is higher, right? Pressure is higher. Here the pressure is lower, high velocity. Pressure is lower. So what happens? High pressure, low pressure. So from here to here, there's going to be a force applied due to that pressure difference, right? Here you can find that pressure difference like P1 minus P2. You can apply the same equation, right? A half rho V2 is squared minus V1 is squared, right? So here, this is V1, right? Here this is V2. So half rho. So what is V2? V plus R omega minus V1, V minus R omega. Okay. So half rho. Okay. So you can get V plus R omega minus V minus R omega minus V plus R omega. Another term V plus R omega plus V minus R omega. Okay. Then get rid of this V. Here you get half rho 2R omega. Here you get R omega cancels off 2V. Okay. Half, let's cancel this. 2 rho R omega V. 2 rho R omega V. So you got that. Okay. Then, but in the answers, there's no omega term, right? So for omega, you can consider this one, right? You know that 2 phi f per second, there are n number of rotations. So you can consider that frequency, rotational frequency, as capital N, right? So instead of omega, just apply 2 phi n, then V. So 2 times 2, that is 4 rho R 4 rho R. There's pi here. 4 pi rho simple R capital N V. Okay. So do we have an answer there? Oh, sorry. What they ask is this is pressure difference, right? This is just the pressure difference, but what they ask is the lift. Sorry, not lift. This unbalanced force, capital F. Okay, so we have found the pressure difference. In order to find the force, you have to multiply that by the effective area, right? So you can see when you take the ball and the pressure forces are applied like this, right? But if you take the resultant pressure forces, you can consider that pressure forces are applied like this on this area. So that area is a circle, right? When you cut the ball in half, the pressure forces are applied on that area. Area of the it is just phi r squared, right? It is the surface area of the ball. For a circle, it is just phi r squared, right? So here you have 4, right? 4 phi r squared r cube rho capital N capital V. Answer should be second one there, right? That is the second answer.